In this tutorial, I'm going to show you a method for creating a curtain such as we see here. It's hanging from a support like a curtain rod and then being pulled back by some type of a device like a hook and getting the nice folds that we can see by using this technique. So let's dock this down in the corner so we can refer to it if necessary. Now let's begin by creating a plane on the plus Z axis. Make a width by 200 centimeters, height leave it at 400. Width segments 20 is sufficient for this. Height segments, let's go 40. So we get kind of square polygons, and then make it editable. Let's name this curtain. Now we select the curtain, go to Simulation Tags, Cloth, and of course if we run that, it'll just fall out of the screen, as we know. Have to have something to attach this to. So I'm going to use a curtain rod I just made with a cylinder here. Simple cylinder, nothing special about it. But it does need to be made editable, or it won't be able to be used as an attachment. So now in order to attach the curtain to the rod, let's right-click on the curtain again, go to Simulation Tags, and add a cloth belt. Now the cloth belt is a way of attaching cloth to something so that it can hang from it, such as this curtain rod. Now in order for that to happen, we need to go to the curtain, turn on vertex mode, select all the vertices across the top where we want the attachment to take place, and then click on the cloth belt tag. You'll see that there are two elements here that we need to use, belt on and set. So belt on is asking for what do we want the curtain to be attached to. That's going to be the rod, so let's just drag that in to that slot. And then as far as how it's going to attach, it will be through these vertices. So we'll just select set. And now if we run our simulation, you'll see that the cloth now hangs from the curtain rod. I've made 300 frames in our simulation here. That's in order to allow plenty of time for the simulation to run its course as needed. So in order to get the curtain to be pushed aside and gathered up here at a tie point, we need to have some kind of an object for pushing the cloth aside. So I've generated already a hook, just made out of a torus, half of a torus, positioning it against close to the edge of the cloth. Need to add a cloth collider tag to it. Let me just show you how this works to begin with, and then we'll make some adjustments. So we begin the simulation and we move the collider against it, and you can see that gathering up there. We let it run about there, stop about there, and so there's our simulation. All right. So there are a few things here that can be done to help improve this. One is that when we run our simulation, oftentimes with cloth we'll get some intersecting of cloth. Let's reset that. Run it again. And we can stop it at any point, like there. Now in order for us, let's get garage shading here so you can see it a little bit more clearly. You can see how the folds are gathered around by the hook. So let's reset that. In order to be able to get a result that can be rendered, we need to animate the hook against the cloth here. So during the simulation, it will perform the move without us manually moving it. So I'm going to center the axis on the hook. Then establish the hook at its starting position. Go to the coordinates, PX. Click the button in front of the P, which sets a keyframe at 0 frame. So we set a keyframe there. Then we choose a frame where we want the animation to stop. Take our hook and move it into our drapery where we want it to end up, and set another keyframe. So now when we run our simulation, the hook will push the cloth aside automatically for us and give us our simulation. Now what you would do is once you've run the simulation, you'd go to the curtains tag, select cache, and you would bake the cache. Now in your version, if you're using version 18 of Cinema, then that says bake cache, but here calculate cache means the same thing, so we'll run the cache. Now we can choose any point along the timeline where we want our curtain to be settled down. Then you can do a render of the curtain at that point, but you can see that it's still kind of in motion here. We need to have it settle down faster, so we need to set some parameters for it. Okay, so let's reset our animation. We'll keep the animation as it is, but let's change some values here. So with the curtain tag, click on that, go to its tag tab, and change some values here. So flexion, just through experimentation, I found that 40% works pretty well for our purposes. Bounce, we don't want it having a lot of bounce, so 2%. Friction, we want the curtain to slide over the hook easily, so we don't want a lot of friction. Let's put at least 2% in there though. And the forces, we're going to add a little bit of drag, 2% drag, which will help slow the simulation down, or the movement of the curtain down. And then let's see what happens when we run that with those parameters. And let it run its course. Stop it there before it gets to 300. And check over our simulation. And it looks pretty good. Just like that. Let's go ahead and put a material on my curtain here to get see our lines a little bit better, our folds a little bit better. And that works pretty well. Could use a little bit more action there in that hook. So what I'm going to do is go back to the cloth tag, go to Expert, and sometimes when you're running cloth simulations, because of all the math that's required here, the cloth is moving too fast for Cinema to do all the proper calculations, and so oftentimes depending upon the speed and complexity of your animation, you can get cloth surfaces penetrating each other. If that happens, go to the curtain tag, go to the expert tab, and check self-collision, and also raise subsampling to something like 5, depending upon your particular situation. And reset it. This is going to slow everything down, but the calculations will be more precise. So let's run it again. Notice that the simulation runs significantly slower, but by setting these expert values, you get a little bit more realistic results. So we can stop wherever you want here. Check your folds to make sure that we don't have too much intersecting. See, there's some intersection right there, but you may not be able to see it from your point of view, in which case you don't need to worry about it too much more. Now, if you need a little bit more, feel like you need more folds, you can reduce the flexion down to a smaller number. Let's go with 20%. And run our simulation again. One of the things that you'll see here is that there's more flexibility, and as a consequence there'll be more jerking around with the curtain as it tries to find its final position. Now if you go back in, you can see that it's got a little bit more folds that may be more realistic. In any case, once you have established your simulation to your satisfaction, then go to the cache and do calculate cache. Anytime you do a cache the data, if you decide to change something, you need to be sure and empty the cache before you run another simulation. Now you can find the point at which you like your folds here, anywhere along the timeline where it looks good to you. And you can come in then, and because we've got, it's a little bit too pixelated, so we can, or too polygonal, so you can come in and child that to a cloth surface, which will help to smooth it out. So the cloth surface, if you go to its object tab, subdivisions of 1, which will smooth it out. It's like a subdivision surface. It's built into the cloth surface. And then the thickness, you want to add as however much thickness you want, 1 or 2 centimeters. Should be sufficient. You zoom in and you can see the thickness of the cloth. Maybe that's too thick. 1 centimeter is sufficient probably for this case. And there's your render. Before you do a render of it, be sure that you cache it. Otherwise, it'll take a very long time to do the render. Once you cache it, then the render will go very fast. So once you've got this established, you can either leave it just as it is here, where everything is still live, or you can select that and do current state to object, in which case you freeze the image at that point and use it as needed.